Hey guys, we're going to do the easy part of tonight's assignment, which is solving absolute value equations. This is always really fun. What numbers can you substitute in for x to make this statement true? What could I put in for x to make it equal to 8? Well, what if x were 8? If I plugged 8 in for x and I found the absolute value of 8, would that equal 8? Of course. So I know that one of my solutions is 8, but think about x equals negative 8. Absolute value of negative 8 certainly equals positive 8, so I have two solutions. So when we're solving absolute value equations, we have to consider that there are two different numbers that could exist inside that absolute value bars that would equal the positive answer there. So the way that works is let's say I have some crazy ax plus b in absolute value bars and it equals c. There are two different separate equations I solve. First, I take away the absolute value bars and I just write ax plus b. But the first time, remember, negative c in here equals this. So I want to know when the inside is equal to negative c. And I also want to know when the inside is equal to positive c. So what that looks like is this. This is kind of like my ax plus b equals c example just a second ago. I'm going to split it into two equations. 2x minus 3 equals 11. And 2x minus 3 equals negative 11, because if this whole thing was equal to 11, its absolute value bar would be 11. If that whole thing was equal to a negative 11, the absolute value of negative 11 is still 11. So both of these options work. And it's just as simple as adding 3 and dividing by 2. And I get 7 for one of my answers. Still going to add 3, but if you look at it, what happens is, before when I added 3 I got 14, but now because that 11 is negative, if I add 3, I actually get negative 8. Divide by 2, x equals negative 4. So my two solutions are 7, negative 4. You can certainly check these. 2 times 7 is 14 minus 3 is positive 11. Well, that's what we got when we set this equal to 11. We got 7. So if I plug negative 4 in, because it was equal to a negative 11, this should end up equaling negative 11. So 2 times negative 4 is negative 8, minus 3 is negative 11. Absolute value of negative 11 is 11, so those both work. This one's a little different. I need to isolate the part that has absolute value in it, kind of like when we were doing the square root method. So the first thing I'm going to do is subtract 2. 7 absolute value of 3x now equals 14. I still don't have the absolute value bars by themselves. I'm going to subtract, not subtract. I'm going to divide 7. Don't subtract, that'd be silly. That leaves me with 3x, or the absolute value of 3x equals 2. Now that my absolute value bars are isolated, I can now set it equal to two different things. 3x equals negative 2, because if this is negative 2, that's cool. And 3x equals 2, because if that's positive 2, it's still cool. Divide by 3, x equals negative 2/3. Divide by 3, x equals 2/3. If you notice, this time I just got plus or minus the same number, but that did not occur up here. So don't just solve it and assume it's going to be the same number, just a positive and negative version of each. Okay, let's look at this next problem here. We're really close to being able to split it into two equations. The difference is that I still need to get that 6 over to the other side. Absolute value of x plus 1 equals negative 4. So what numbers could I set this equal to? If I set that equal to 4, if this is 4, is it ever going to equal negative 4? The absolute value of 4 equals negative 4. Well, no, that doesn't work. What about the absolute value of negative 4? Well, that still doesn't work because that's positive 4 and that's negative 4. So what happens is when we set a situation like this, where the absolute value equals a negative number, this is not possible. So instead of giving numbers as answers, I would say no solution. Woohoo! Whoa! Okay. This one's also kind of an exception to the split it into two equations rule, because after I subtract 4, I end up with 0. But we don't have a positive and a negative 0, we just have 0. 0 has no sign. So in this case, there's only one number that's going to go in for x to make it equal to 0. So I can just kind of ignore the absolute value bars and just set it equal to 0. So I add 2, divide by 3, x is 2/3. So one solution. So going back, if my absolute values equal a positive number, like they equaled 1 here and they equaled 2 here, I'm probably going to get 2 solutions. Actually, you'll get 2 solutions. If my absolute value equals a negative number, that's not possible, so there's no solution. If it equals 0, there's only one number that's going to provide a solution. And I believe that's the end of the notes. I do have a lovely bad joke of the day. You can make fun of me tomorrow if you like. What did Mickey say when Minnie asked if he was listening? Because we all ask the guys when they're listening, right? His response was, "I'm all ears." This is Mrs. Lauer signing off. See you in class tomorrow.